This conference is brought to you by CodeStack, React and React Native development experts.
Hello everyone and welcome to our talk. I'm super happy to be here. It's actually my first time speaking for Microsoft. It's really exciting for me. So today I'm going to talk with you about improving all the repositories. And by that I mean improving the RNEU, which probably for most of you doesn't mean anything. And that's, it's on purpose. It's a joke because you see at Microsoft we like a lot to use acronyms. So in this case, what I'm talking about is actually the developer experience when it comes to React Native at Microsoft. You see, at Microsoft, many things are kind of complicated or like super big and super, weird sometimes to interact with. So we decided to come here and talk to you about some of the challenges that we're facing and also present to you some of the solutions that we come up with, because we think that some of them you can probably take with you, both metaphysically and maybe technically. Let's start with one major concept. So as I'm saying currently, Microsoft is really big, and as a corporation with many companies and many products, we have a ton of different code bases, and many of them are monorepositories. And a monorepository is basically a big repo in which each folder is its own package, its own library, and it's aware of the other folder next to it. So it doesn't need to install through npm package.json. You can refer directly between the different folders. And we have many of those things, and sometimes we need them to even communicate among each other. So in a way to describe this complexity, we decided to go for something really big and complicated like the galaxy. And as you can see in this picture, we have decided to show the different monorepos as solar systems, because again, it's not just a planet. It's literally like its own living system where things work, but also sometimes you have relationship between those. So this is kind of like our starting point. This is where we want to, set the stage. So to introduce you to our cosmos, I'm going to be one of your astronauts. I'm Lorenzo Sciandra. You may know me as Kelset. I'm a senior software engineer at Microsoft, and I'm also a React Native maintainer. And with me is...
Hi, I'm Nguyen. You may know me as Tito64 on GitHub. I'm a principal software engineer at Microsoft. Long-time open source contributor, but first-time speaker.
And we're really excited to be both here. As you can see, we come from two different solar systems, which is one of the cool things about being in this kind of big company. And also, as is one of the reasons why we decided to work on these problems, because we're from different parts so that we can collaborate. But before we do that, Tommy, how about you tell us a bit about, how React Native came to be at Microsoft? Let's start from there.
Sure. So, as in most companies, whenever new tech comes out, like React Native, someone needs to go and do the exploration work. And that someone, at Microsoft was basically the Skype folks, what they did a few years back when they rewrote their mobile app as a greenfield React Native app. And thereby demonstrating that you can use JavaScript to create delightful experiences and still achieve native performance. And I think what naturally followed that was that other teams started looking into ways to leverage this new technology to bring existing features that were written for web at the time, and then bring them to our users on mobile devices, on their PCs, laptops, and so on. And that's essentially how the brownfield approach started at Microsoft. Today we have React Native experiences in many Office apps, including Outlook and Teams. But we started out with one team making a proof of concept that got copied by other teams, that again got copied by other teams, and so on. And that way, the approach organically grew within Microsoft. And that's also how this concept of experiences came to be. Previously, one would have to go directly into an app, like, for instance, Outlook, in order to write the feature that you would want inside of that app. But with the brownfield approach, you can now stay in your own repo, say repo A here, write your experience, and then when you're happy with it, you can integrate it into repository B here, and that will eventually be shipped into a product like Outlook or Teams or some other app. And that's basically how we kind of abstract away the complexities, of being writing one experience, but integrating it into many, many apps within Microsoft.
And that's pretty interesting, but also comes with a series of challenges, right? So let me kind of like throw you some of the challenges that we're facing. As I was mentioning earlier, we have the system of monorepos, and sometimes we need to send code between them, as also Tommy was showing earlier. So, for example, one problem when we try to do this, and it comes to React Native experiences, is like, who keeps React Native up to date in each code base? Does it mean that every monorepo needs a team that knows how to do a React Native upgrade? Or like, even when you do the bump, like if I'm on 61 and you're on 62, it doesn't mean that I need to rush to 62. Does it mean that we go together to 63? Or like, what if our configuration are even more different? What if I'm using whole and you're using Metro, or I'm on 62, you're on 64, and we use different libraries? What if my code that I'm writing inside my code base needs to go on two different monorepos and they have different configurations? How can I make sure that it works for both of them? More in general, like, how do we handle open source libraries? Like, what if I want to use React Native SVG? How do I make sure that everyone is using the same version so that the same code doesn't create problems? Some of these challenges are really, really complicated. And today, what we're going to try to do is dive on two of those. We have picked these two because they're kind of the ones where we know the answers and we think that the answers can be of use to you too. So let's start with the first one. How can we separate the developer experience from the complexity of the tooling? This is something that Tommy kind of briefly touched on, but I'll dive into it a bit more. And the second problem is, how can we reduce the burden of alignment across different monorepos? This is what I was just mentioning. And by saying burden of alignment, what I mean is that we want something that is automated. We want something that doesn't need to rely on some human necessarily to do the entire alignment process every single time. But let's start with the problem number one, separating the developer from the toolchain. So bringing back up the graphic that Tommy was showing, what we can see here is that we have codebase A, we have the developer working on the experience, and then this goes into codebase B and then gets deployed into the host app, in this scenario, Outlook Mobile. How can we make sure that the developer is capable of creating the experience, test it, and then it will go through correctly? Some of you may think, well, you can just give the host app and the codebase B to the developer so that they can build the app and then they can see the feature working within that app. But when you're a company of size of Microsoft, this is not viable. There are many different reasons. There are security concerns, there are authorizations problem, and there's also like a more practical reason, which is if you were to keep two massive code bases on your machine, and every time you need to build the final host app, it takes 30 minutes, it would be a lot of time wasted and a lot of processing power that needs to go to, for maybe you're just developing a small sub page with a button. You don't really need the entire app to work. So what we decided to go for, and what we want to achieve, is basically the idea of a sandbox, something that you have locally in your code base that replicates well enough the environment that you will have in the final host app so that you can develop in isolation. We call this sandbox the React Native Test App. And the way you can think about it is basically kind of like a React Native init app, with the difference that it's way less complicated because we squashed most of the complexity below the surface. And by doing so, it means that the developer only needs to have it set it up, and they can just put their JavaScript code in there. They don't need necessarily to worry about the native side, and they just can keep iterating on it. In that sense, it's kind of similar to the Expo client, like where the developer only needs to worry about the JavaScript code and not necessarily about the native. But when it comes to it, and this is probably the difference with the Expo, is that our React Native Test App allows you to modify whenever, in whichever way you want, the native code. And also, thanks to hiding the complexity of the native side, we are also able to support many different versions of React Native all at once. And you will see soon what I mean by that. Because, it's fine and dandy to say that our solution is perfect and is really, really good. But a completely different thing is to show it to you. So, Tommy, how about you do as Sun Tzu says here and show us how React Native Test App works?
Sure. Let's start with integrating React Native Test App into React Native Web View. So here you see that I have a clean checkout of React Native Web View. Just to show you, there's nothing I have done in here. So the first thing we'll do here is to move the existing example app out of the way. Right, and then we'll install React Native Test App, and then we will initialize a new test app. We will call it WebView Example for now. And then we'll select the platforms that we will support. I know that WebView supports both Mac OS and Windows, so I'm going to keep those. Now, let's have a look inside this newly generated app. You can see that it's very bare bones. There's a few configuration files. Inside the iOS folder, there's only a pod file. The Xcode project will be generated much later. For now, let's copy over some of the code from the previous example app. And that's it. Now, before we build, let's take a look inside package.json. You can see here that when we generated the new app, React Native Test App will try to match the React Native version that the library is using. I'm going to bump this to 62.3 because I'm using Xcode 12.5 and I want to avoid build issues. Next, I'm going to add React Native Web View. Right, and then we will run yarn and pod install as we normally would. And then we'll start the build. So in a moment, we should see the WebView test app launching. And just to show you that it works as normally, I'm going to click around this button here. And if we go back now, we see that we are running React Native 62.3. But setting up the new app, that's the easy part. Let's have a look at how you would bump React Native. If you've done this before, you know it's not a very easy process, especially if you're unfamiliar with Gradle, Xcode, or Visual Studio. So now we need to bump a few packages inside of package.json just to make sure that we don't hit any issues. We're going to bump these as well. All right, now we're going to run yarn and pod install just like before, but we need to remember to clear out the pods files just to make sure there are no old files lying around causing trouble. All right, now we can run pod install again. And we'll start the app just like before. And there we go. That's it. You can see it works just as normally. I can click on this thing here. And if we go back, it says that it's running 63.4. And that's how easy it is to bump React Native using React Native Test App.
That's pretty dope.
So, as you see, previously when we had I briefly mentioned that we copied the patterns from other teams, and sometimes we would verbatim copy the test app code as well. And so many teams had their own test app, and so they had to maintain their own test apps. And whenever we did a bump to React Native, they would all have to go and upgrade their test apps as well. And so, it's time consuming for everyone. But with React Native Test App, you have a single test app where we do the bump, and then the teams using it just need to do a bump inside of package.json, and then they don't have to worry about tweaking the project files in order to make it work, and other not all people have domain knowledge within Xcode or Visual Studio in order to do this. Now we basically hidden away all of the complexities inside the React Native Test App, so you don't have to worry about it. And the nice part about it is that when there's a fix or a bug, you can apply them once inside a React Native Test App, and then have them propagated across all of the teams, and they will all benefit from it. If you have a new feature implemented inside a React Native Test App, everyone will benefit from it, not just your own team.
And also because it works on so many platforms, it means we can help a lot of people at the same time. So it's either iOS, Android, macOS, or Windows. It works with all of them. So that's pretty interesting too. But let's stop this hype train about React Native Test App, and let's go back to talking about problems. That's what I like to do, talk about problems and complain. So let's talk about aligning the monorepos, the second problem I was mentioning. So as I was saying earlier, it could be that you have your monorepo and you're using React Native version X, but maybe there's another one, and apparently, they're using React Native version X, but then you realize, I'm using package.b version 2, but they're using version 1. Or what if they're using React Native version Z or React Native version Y? And what if they're using Hermes, but I'm not? There is a lot of independency between these different monorepos, but this can lead to problems when it comes to sharing code. So basically what we need to ensure that these kind of problems don't arise is some sort of antenna that propagates a signal to all these different configurations and kind of aligns them. We have decided to call this tool, this antenna, DevExp. Basically, this tool understands the structure and the dependencies within a package.json and can modify it based on a series of curated profiles. What happens is that DevExp can read through all the different dependencies, and let's say you told the tool, hey, I want this package to be ready for 64, then DevExp has a profile that tells it, okay, if you're on 64, you need to be using React Native SVG this version. You need to be using React this version, and it will modify the package.json accordingly. And not only that, but it can even fix misconfigured packages.json. Like if you're using a library, or like you're working on an experience which is a library that then you send to a different app, you need to configure, for example, the peer dependencies so that whenever another package consumes you, they know which version of things they need to use. So sometimes that can kind of fall off because it's not strictly mandatory. So this tool can also fix the misconfigurations, and you'll see that in a few minutes. Also, another really interesting part about DevCheck is that since it's a CLI, it can be mostly automated. But let's stop talking about it. Tommy, how about you tell us a bit more about DevCheck?
Sure. So in this monorepo, we have hundreds and hundreds of packages. Let's imagine that. So in this repo, there's a nice library that we'd like to consume. This library is already configured to use RNXKit. You see that it has support for 63 and 64. This is also reflected at the bottom in the configuration here. But it has a direct dependency on React 17, which is troublesome because React Native 63 will install React 16. And if you're consuming this package, you will get both 16 and 17 installed. And that will cause issues. Our next DevCheck will fix this. You can see here that it tells you to remove React from dependencies and move it down to dev dependencies. And then under peer dependencies, it tells you to add 16 and 17. And this is all according to the configuration that you put at the bottom here. Let's have a look at another library. So this one is actually perfectly fine. Everything is correctly configured, but I want to add WebView, but I don't know which package to use. So I'm going to open this up, and in the configuration section down below here, I'm going to say I need WebView capability as well. So one of the things that RNX DevCheck does is that it will suggest which package to use. And in this case, it will be React Native WebView at 11.4.2. That's pretty neat. Now, let's have a look at an app that consumes both of these libraries. So here's one app that consumes another library and nice library. It also has a slightly older version of React Native, but that's okay. We'll fix that in a bit. So we run RNX DevCheck, and you'll see that it tells us to bump to 64.2. And also, by the way, it picked up that another library has a dependency on WebView and tells you to add it as well. But all of these so far depend on a configuration. What if you have a package that don't have a configuration? What do you do then? Well, RNX DevCheck hopefully will be useful in that case as well. So here we have a test app that doesn't have a configuration. It also has the same problem as the previous app, that it's using a slightly older version of React Native. We're going to add a flag here called vigilant and tell it to use the 0.64 profile. Basically, that will tell us that we want to use React Native 64, and it will tell us that we should probably bump it to 64.2. You can also use this tool at the top level of your repository, so you can get an overview of all of the problems that we've seen so far. You can see here it just dumps all the problems that we saw earlier. And then to fix this, just add --write. And it should fix it up. we'll see that in the Git diff here. All of the changes that it suggested earlier has now been applied, and you need only commit this and you're done. So this is how we use this internally, is that we integrate it directly into our CI. We run it every time a PR is submitted, a build is started, and so on. The RNext step check runs, and then it will tell the user if they need to make any changes to their package JSONs. And the way we have also integrated it so that it will actually post a comment on the PR with suggestions, so that you just click a button and the suggestion gets applied directly onto your branch. So this ensures that everyone inside of your monorepo are using the exact same version of React Native Web View, and what have you. But also, since many monorepos are using the same tool, we ensure that they are all aligned. Additionally, if your monorepo publishes a lot of packages, what you can do is to export a custom profile and say that, for React Native 64, you should be using these versions of my packages. And then you export that profile to other monorepos. They can apply that to RNext step check, and thereby making sure that they also stay aligned on the correct versions of the packages for the respective React Native version.
And that's super powerful, in particular for what we were saying earlier about removing the burden. It's awesome. So now, trying to recap a bit. So React Native Test App, we introduced that to separate the developer experience from the complexity of the tooling, and that check, as we were just saying, to reduce the burden of alignment across different monorepos by relying on the automation. Now, so we are kind of like concluding here. So as we were mentioning at the start, I wanted to go back to the fact that these are basically byproducts of the lessons we learned the hard way, the challenges that we were facing. And while we realize that Microsoft is a really big company and not many of you may have the precise experience that we were having, you may still find some challenges that are kind of similar. Like, what if you have a React Native library and you want to make sure that it's configured correctly? What if your library doesn't have a test app, or like you added it, but it's always out of date because you don't have time to upgrade it? These tools could be useful for you too. So how about we make this tool open source so that you can use them? I mean, this is the oldest trick in the book, but hey, we're introducing you all the different tools that we were just discussing. So React Native Test App and DevCheck are both available through the repos you're seeing right now on screen. React Native Test App is in its own repo, and then DevCheck is in the RNext Kit repo. It's one of the packages in that monorepo. Also, you can find in RNext Kit quite a few interesting small little tools that may be interesting. So check out the repo and look at the other elements that you may find there. Anyway, thank you for listening. We hope that you will, find a little bit of happiness in using these tools for yourselves. And we hope you're enjoying our conversation. I was Lorenzo, with me was Tommy. We're really, really happy to be here. And feel free to shoot messages our way and ask us questions. All right, goodbye.
Goodbye, and thank you again.
Thank you.